All right, for today's video, we're going to be talking about how to solve rational equations. Now, when we're looking at rational equations, I'm going to split this into two parts to kind of give you a little bit of time to process exactly what's going on. So when we have a rational equation, now remember, a rational equation is when I have the format of division. So like I have a function divided by a function, okay? And when we're looking at that, we also have to remember that the denominator can never equal 0. So that bottom function can never equal 0. So a few key things that you're going to have to know when you're talking about rational functions and solving. The first thing is that where do the solutions actually come from? When you're looking at a rational function, you can determine a lot of things. You can determine a lot of key features from just looking at the equation. So when we did rational functions before, we learned that whatever was in the denominator was a discontinuous piece of the function. What we're going to learn about today is whatever is in the numerator, or whatever is left in the numerator, is actually your solutions. So I know that in my denominator that this piece right here, that x can't equal -5 because it can't equal 0. But I also know that x minus 3, okay, that is an x-intercept, and x-intercepts are solutions. So if that's going to be a solution, then I know that x equals 3. All right, that also applies when you have, let's say, factors. So if I have something in common in the numerator and the denominator. So if I have x minus 3 in the top and x plus 5, and then I have x plus 5 in the bottom. So I have two common factors. That still is going to leave me with x minus 3 in the numerator. So that's still going to give me a solution as x equals 3. Okay. Now, we're going to actually learn how to do some big equations with rational functions. So we're going to learn how to find the least common denominator. So the least common denominator is, the reason we have to find that is because we can't add or subtract fractions unless they have the same denominator. They have to have the same whole. And what I mean by the same whole, so a fraction is part over whole. And we can't add or subtract something unless the whole or the denominator is the same, okay? So we have to make sure that they are equivalent in the denominator. So we are going to learn how to multiply in order to find those fractions and those least common denominators. Now, here's the thing about this, is that we're going to have what we call extraneous roots or extraneous solutions. So when we're solving these, when we multiply or divide and we multiply or divide variables, sometimes they will produce solutions that don't actually exist in the original equation. So we're going to have to check our solutions to make sure they actually work, okay? So I'll say that one more time. Extraneous solutions occur when we multiply or divide mathematically those x values or any variable, those expressions, okay? And they will produce solutions that may not actually exist. So we got to check. So what we're going to do is we're going to practice. We're going to just go ahead and jump right in, and we're going to talk about what it means to find the least common denominator. So just to kind of give you an example. So let's say that I have 1 over x, and I'm not going to solve this. I'm just going to talk about what it means. So let's say I have 1 over x, and then I have x over x plus 3. So I do not have a common denominator. One of my denominators is x, and the other denominator is x plus 3. Now, one of the most common things that students get incorrect here is they'll say, okay, I have an x here and an x here, so the only thing I have to worry about is the 3. How can I produce that 3 further? This is all together. This is x plus 3. You can't assume I have an x, and how do I do the plus 3? That's not how it works. So what I do have is I have an x on this side, and I have an x plus 3 on this side. So my least common denominator is going to be the product of the two. So product means we're going to multiply. So my least common denominator is going to be x and times x plus 3. Why is that going to occur? Well, that's going to occur because I'm going to have to multiply this side times x plus 3 over x plus 3. And then I'm going to have to multiply the right side by x over x. Now again, why do I need to do that? Because then I will have the same denominator on both sides. If I multiply x times x plus 3 and x plus 3 times x, that will give me the same denominator. Now, let me also draw your attention to, why can I do this? Well, I can do this because if I look at x plus 3 and x over 3, all that really is me calling this the number 1. So this all just equals 1, okay? So that whole problem itself just equals the number 1. Because x plus 3 over x plus 3, they cancel out, leave me with 1. X over x equals 1. So I can multiply by those, as long as I do it in the top and bottom, I can still multiply by those values. Now, we're going to learn how to kind of work our way through that without having to do that much multiplication. But the least common denominator is having all of the denominators represented and all of the expressions represented, okay? So, from there, we're looking at this problem. So, I have an x plus 6 over x equals 5. Now, what I notice here is I need to turn this into a fraction. And I have, in my denominator, I have a 1 and I have an x. Now, my least common denominator here is the product of the two. So I have x and 1. So my LCD, or my least common denominator in this problem, is just going to be x. Okay? So my LCD, or my least common denominator, is x. So how do I do that? Well, I'm going to handle that situation by simply multiplying my entire problem by x. I'm going to multiply it by the LCD. So what's going to happen here is I have x times x. That's my first problem, my first term. Then I'm going to multiply it again. So then I have plus x over 6 times x equals, and then I'm also going to have 5 times x, and then 5 times x. Now, I'm writing this out to show you the whole process, but this multiplication you don't necessarily have to multiply out. I mean, you're going to know what x times x is. So when I multiply this, I have x times x is going to give me x squared. Then I do not have to have a common denominator to multiply, so this is 6 times x is going to be 6x over x. And then that's going to give me 5x. Now, why does this work for us? Well, it works because now that x over x is going to cancel. So we now have x squared plus 6 equals 5x. So we're going to have a quadratic here. So when I'm looking at this quadratic, my best method is to go ahead and move everything to the same side. And that's going to give me x squared minus 5x plus 6. And we can factor this. And why do we want to factor? Because we want to find those roots, those common zeros. All right, so we're going to look and we're going to figure out what do I need to multiply by to give me 6, but when I add together it gives me negative 5. So the most common thing that students jump right to is, well, 1 and negative 6. Well, 1 times negative 6, though, is not going to give me a positive 6. So what I need to do is the other option is going to be 2 and 3. So we have negative 2 and negative 3. All right, so negative 2 and negative 3. So we have x minus 2, x minus 3. And then we can split them up into two separate pieces. So we now know that x minus 2 equals 0. So if we add 2, we know that x equals 2. And then we have x minus 3 equals 0. Add 3. And then we have x equals 3. But again, you need to check these just to make sure that your pieces don't have any extraneous roots. So we're using 2 and 3. So I have x plus 6 over x equals 5. So what I'm going to do is I'm actually going to pull up Desmos. And I had x. So we're going to start with the number 2. So let's go to number 2. So I have 2 plus 2 over 6. I think it was. Actually, it was 6 over 2 equals 5, right? So did that equal 5? All right, so that does equal 5. All right, so the other option is we had 3. So did 3 work for both of them? And 3 works for that one as well. So both of my solutions work. So we have 2 solutions here. That's going to be 2 and 3. Okay. All right, so again, I have another problem here. I'm asking you to solve this rational expression. So I have x over 1 over x minus 3. So I have x, we'll put it over 1, plus 1 over x minus 3. So we have 2 pieces in the denominator. We have 1 and x minus 3, equals 1. So if I find the product of the 2 or find the least common denominator, my LCD is going to be x minus 3, because 1 times x minus 3 is still x minus 3. So now we're going to multiply x minus 3 to this entire problem. All right, so when doing that, so I'm not going to draw, the arrows this time, but we're multiplying this entire thing to all 3 pieces, okay? So I have x times x minus 3. I would definitely put that in parentheses just to remind myself that I'm multiplying the whole thing, plus 1 over x minus 3 times x minus 3 equals 1 times x minus 3. All right, so we're going to have to do just some distributing here. So this is going to turn into x squared minus 3x. So 1 times that's going to be x minus 3 over x minus 3. And then 1 times x minus 3 is going to be x minus 3. All right, so we should be able to determine here that I have x minus 3. That's going to cancel. However, there still is going to be a number there. That is another common mistake that students make. If you have all pieces cancel, you're still left with the number 1. So it looks like we are again going to have a quadratic, but we need to move everything over. So I'm going to subtract my x, and I'm going to add my 3. All right, so those are gone. So that leaves me with x squared minus 4x plus 4 equals 0. So we're looking for 2 numbers that multiply to give me positive 4, but when added together, they give me negative 4. So that's going to be negative 2 and negative 2. So we have x minus 2 times x minus 2 equals 0. Now, obviously, if I take both of these and I set them equal to 0, they're going to be the same. So I have x equals positive 2. So let's check that that is correct. So I'm going to pull Desmos over here. All right, so we have 2 plus 1 divided by 2 minus 3, and that should equal 1. That is correct. All right, and we have one more example of just the basics. So this time I have more than one denominator. However, my denominator, my LCD, is not going to change significantly. So the part 1 is really going to be just about making sure you have the process down, and then we're going to kind of upgrade the LCD in the next lesson. All right, so I have multiple pieces here. So when I'm looking at this, I have this over 1. Okay, so again, this time I'm looking at my denominators. I have 1, x minus 3, x minus 3. That doesn't change that my LCD is the product of that. So my LCD is still going to be x minus 6. So I'm going to take this whole problem and I'll multiply it by x minus 6. All right, so I'm going to do negative 6 times x minus 6. Minus 6 over x minus 6 times x minus 6 equals negative x over x minus 6 times x minus 6. So we can see that I have, in doing this, I've distributed to every piece in my problem. All right, so let's simplify some here. So we have negative 6x plus 36 minus, and I would technically be multiplying my 6 and my 6 minus x, but I can go ahead and cancel those out because I know if I multiply that to the numerator, I'm going to have a top and a bottom that are the same. So I can cancel those out. That's going to leave me with minus 6 equals negative x times x minus 6. And again, actually before I make all that into something more than needs to be, I can see that I'm going to have a top and a bottom that are the same. That leaves me with negative x. So this problem actually wound up being a lot simpler than it looked initially. So I can go ahead and simplify this and solve it. So I have my x's. I need to get all my x's on the same side. So I'm going to go ahead and combine like terms. So I have negative 6 plus 30 equals negative x. And then I'm going to add 6x. So then I have 30 equals 5x divided by 5. And x is going to equal 6. All right, so again, I can plug that in. And when I plug that in, I have negative 6 over 1. Well, I don't even need to put that over 1. Sorry. Minus, and then I have 6 over 6 minus 6. And that is going to equal undefined. So actually, this problem itself has no solution. All right, so how can I verify this? Well, and remember just a second ago, I said in this problem initially that the solution is the x-intercept. So when I come and I look at this original problem, if I graph it like it's an actual function, and I look at it, and I can't do minus 5, so I'm going to take that 5, and I would technically subtract it over, so that's going to be minus. I can see that it does hit the x-axis twice, and it hits it at 2 and 3. So I had to actually turn it into a y equals. Just like for this next one, to turn into a y equals, it would be y equals x plus 1 over x minus 3, and then that would be minus 1 because I would subtract the right over. So I have y equals x plus 1 over x minus 3, and then that minus 1 is on the outside. So again, I can see it hits the x-axis that one time at 2, which is what we got. So then we come to this problem. So when I actually go to graph this one's going to be y equals negative 6 minus 6 over x minus 6. And I'm going to add that whole piece over because it was negative. So I'm going to add the whole thing over. So y equals negative 6 minus 6 over x minus 6. And plus 6 divided by x minus 6. All right, and what are you going to see? You're going to see that it actually is a linear function, and that linear function is never going to cross the x-axis. Okay, it's going to keep going because it is horizontal, so it's never going to cross, so it's no solution. All right, so again, for this first section, we're going to practice just learning how to identify a basic LCD, and we're going to learn how to find the solution. You can verify in your calculator, but I do want you to practice doing this by hand. Again, this is when you take your first college math course, especially if it's like a college algebra. Most time they expect you to do these by hand, so I want you to go unprepared. And you are going to do part 1 of these solving rational expressions.